Hi students, now I am going to teach a topic of relation between input I and output theta. Let's start the topic. Deflection torque TD is derived in transient period only, that is in dt seconds. The next so let's take a dt seconds with respect to time I of t. So let's go by inductance formula. L is equal to N phi by I. So N phi is equal to Li. Differentiating above equation, N d phi by dt is equal to I dl by dt plus L di by dt. Finally, V is equal to I dl by dt plus L di by dt. So the next, since V directly proportional to N d phi by dt, the next, multiply the above equation both sides, multiply I dot dt above equation V dot I dt is equal to I dl by dt plus L di by dt I dt. Then next, so simplifying above equation, Li di plus I square dl is equal to dW. Equation number 1. What is dW? The total amount of energy drawn from the source at time dt seconds. This total amount of energy, is converted into mechanical energy. That is spindle rotation. Then next, energy stored in fixed coil in dt seconds or change in stored energy in dt seconds is equal to energy stored in t plus dt seconds minus energy stored in t seconds. Energy stored in t seconds is equal to half Li square. Next, energy stored in t plus dt seconds is equal to half L plus dl I plus di whole square. Now, energy stored in fixed coil in dt seconds is equal to half L plus dl I plus di whole square minus half Li square. So this gives rise to half L plus dl I square plus di square plus 2i di minus half Li square minus half Li square. So this, when simplification, this gives rise to Li di plus half I square dl. This becomes equation 2. The next, mechanical work done. Mechanical work done in dt seconds. Mechanical work and in dt seconds is equal to Td d theta equal to Td d theta. This is equation number 3. According to law of conservation, equation 1 is equal to equation 2 plus equation 3. Then this gives rise to, what is equation 1? I square dl plus il di equal to half I square dl plus li di plus td d theta. So this gives rise to I square dl minus half I square dl is equal to Td d theta. Half I square dl is equal to Td d theta. So finally Td is equal to half I square dl by d theta. If dl by d theta is constant, then Td directly proportional to I square RMS. So it is a non-linear scale. The next spring mechanism is used. Spring mechanism is used to produce controlling torque. Spring mechanism is used to reduce controlling torque. So Tc is equal to Kc theta. The next step, if spring is broken, controlling torque equal to 0. Current is passing through the coil. Current is passing through the coil. Pointer swings to full scale deflection value and indicates full scale deflection value. The next step, air friction damping is used. Air friction damping is used. At final steady state position, Tc equal to Td. Kc theta is equal to half I square dl by d theta. Theta equal to half I square by Kc dl by d theta. So then next again, theta directly proportional to I square RMS. It is a non-linear scale. The next step, what about your non-linear scale? So they are cramped, means they are very near. They are very near. Then next, linear scales. So linear scale. This is linear scale. The next, you go for expanding. You go for expanded. The next time, MI instrument as not pure square law scale. Next, MI instrument has pure square law scale. The next choose range of MI meters. Choose range of MI meters such that the value measured should enter into linear portion. Otherwise, gross errors are present. Otherwise, gross error are present. The next if current frequency is 50 hertz, instantaneous torque is 100 cycles. TD directly proportional to I square RMS. The pointer has to make hundred oscillations in 1 second. Pointer has to make 100 oscillations in 1 second. It's not possible. It's not possible practically hence pointer response only for average torque. The next if low frequency hazards is given. Pointer makes oscillations. Pointer makes oscillations. Hence, it is not used. Hence, it is not used for below 5 hazards. The next point. MI instrument works for both AC and DC. For DC measurement, accurately, we use PMMC. Therefore, MI used only for AC. MI instrument used as AC ammeter and AC voltmeter up to 50 amperes and 750 volts. The next step, by using MI instrument, we can measure AC, DC, current, voltage, but not power. Next point, MI instrument does not indicate same reading for same AC and DC voltages. For same AC and DC voltage, because of frequency effect. The next 200 volts VDC. IDC is equal to 200 volts VDC by R. The next 200 volts VAC. IAC is equal to 200 volts VAC by Z. This is 200 volts VAC by Z. Say simply what Z is greater than R. Z is greater than R. So what? IAC less than IDC. The next my instrument indicates less value for AC component compared to DC for the same AC and DC voltages. My instruments practically used for 50 hazards. This range limited by coil magnetic field saturation. The next dynamometer instrument used as transfer type instrument for power frequency 50 hazards. Thermocouple instruments used as transfer type instruments for audio frequency. Let's see extension of MI instruments in the coming lecture. And a problematization on MI. Thanking you.